The universe is immense, almost beyond our human comprehension. Stars stretch out in their billions like grains of sand on an infinite beach. Around many of these stars planets orbit, some perhaps like our own Earth. For centuries, humanity has gazed at the night sky and pondered a fundamental question. Are we alone? Is life on Earth a unique accident, a singular spark in the vast cosmic darkness? Or could it be that life in some form is a common occurrence throughout the cosmos? The idea of extraterrestrial life is not just for science fiction stories anymore. Many scientists now believe that discovering such life might be closer than we have ever thought, perhaps even within our own solar system. When we speak of life, it is important to broaden our definition. We are not necessarily searching for complex intelligent civilizations capable of building starships. Instead, the first extraterrestrial life we encounter might be very simple. It could be similar to bacteria, tiny single-celled organisms that were the first forms of life on our own planet. Even viruses, which exist at the very edge of what we define as living, could represent a form of extraterrestrial biology. Finding such microbial life would still be a monumental discovery. It would tell us that the spark of life can ignite in places other than Earth. This realization would fundamentally alter our understanding of our place in the universe and the nature of biology itself. Earth itself provides fascinating clues about where life might exist elsewhere. Our planet is home to extremophiles, organisms that thrive in conditions we once thought were too harsh for life. Some bacteria live in the boiling water of hydrothermal vents deep beneath the ocean. Others survive in extremely salty lakes or in acidic environments. There are even microbes found frozen within Antarctic ice and some that can withstand high levels of radiation. These tenacious Earth-based organisms demonstrate that life is incredibly adaptable. If life can flourish in such extreme places on Earth, similar environments on other planets or moons could potentially support their own unique forms of life waiting to be found. The search for life, therefore, extends to places that might seem inhospitable at first glance. We must look beyond Earth-like conditions. The presence of liquid water is considered a key ingredient for life as we know it. However, the resilience of extremophiles suggests that life might find a way even in suboptimal conditions. This opens up a vast array of possibilities within our solar system and beyond. The quest is not just about finding another Earth, it's about understanding the full spectrum of conditions under which life can arise and persist. The universe is full of diverse environments, and life might be just as diverse. Within our own solar system, several celestial bodies have captured the attention of scientists searching for life. Jupiter's moon Europa is a prime example. Beneath its thick icy crust, evidence strongly suggests the existence of a vast saltwater ocean. This ocean could be miles deep, potentially containing more water than all of Earth's oceans combined. Importantly, tidal forces from Jupiter's immense gravity could be kneading Europa's core, generating heat. This internal warmth could create hydrothermal vents on Europa's ocean floor, similar to those on Earth where rich ecosystems thrive, independent of sunlight. Such vents could provide the necessary chemicals and energy for life to emerge and sustain itself in the dark depths. Another tantalizing prospect is Saturn's moon Enceladus. This small, icy moon surprised scientists when the Cassini spacecraft discovered plumes of water vapor and ice particles erupting from its south polar region. These geysers shoot hundreds of miles into space, indicating a subsurface liquid water source. Analysis of these plumes revealed not only water but also organic molecules, salts, and silica nanoparticles. The silica suggests hydrothermal activity, again pointing to a warm, chemically rich environment beneath the ice. Enceladus's ocean seems to be in direct contact with its rocky core, creating conditions that could be very favorable for the origin and sustenance of microbial life. It is a truly exciting target for future exploration. Mars, our reddish neighbor, has long been a focus of the search for extraterrestrial life. Evidence clearly shows that Mars was once a warmer and wetter planet. Billions of years ago it had rivers, lakes, and possibly even oceans. While the surface of Mars is now cold, dry, and bombarded by radiation, conditions might have been suitable for life in its ancient past. Current missions like NASA's Perseverance rover are actively searching for signs of past microbial life. They are collecting rock and soil samples that could contain biosignatures, which are chemical or physical traces of ancient organisms. The hope is that these samples, when returned to Earth, will provide definitive answers. Furthermore, the possibility of present-day life on Mars cannot be entirely ruled out. While the surface is harsh, life could potentially exist underground. Subsurface environments might still harbor liquid water, perhaps in briny aquifers, shielded from the harsh surface radiation. Scientists have detected methane in Mars's atmosphere, a gas that on Earth is largely produced by living organisms. While geological processes can also produce methane, its presence is intriguing and warrants further investigation. Future missions aim to drill beneath the Martian surface to explore these potential habitable niches. Discovering life on Mars, past or present, would be a profound moment for humanity. Our search for life is not confined to our solar system. We also listen for signals from civilizations that might exist around distant stars. One intriguing phenomenon is the fast radio burst, or FRB. These are incredibly powerful yet very short bursts of radio waves originating from deep space. Most FRBs are one-off events, but some have been observed to repeat. While many natural astrophysical explanations are being explored, such as magnetars, highly magnetized neutron stars, their exact cause remains a mystery. The regularity of some repeating FRBs has led to some speculation, however remote, about whether they could be artificial in origin, perhaps beacons from an advanced civilization. A famous historical example in the search for extraterrestrial intelligence, SETI, is the WOW signal. Detected in 1977 by the Big Ear Radio Telescope at Ohio State University, this was a strong, narrowband radio signal lasting 72 seconds. It appeared to come from the direction of the constellation Sagittarius, and bore many hallmarks of a potential extraterrestrial origin. Despite numerous attempts, the signal has never been detected again. Its source remains unidentified and unexplained, a tantalizing puzzle in the annals of SETI. While not conclusive proof, such events keep the hope alive that we might one day receive an unambiguous message from the stars. In recent years, another type of unexplained phenomenon has entered public discussion: unidentified aerial phenomena, or UAPs. These are objects or lights observed in the sky that cannot be immediately identified. Governments, including the United States, have declassified footage and reports from military pilots and sensor data showing these UAPs. These objects sometimes exhibit flight characteristics that appear to defy our current understanding of aerodynamics and propulsion. While many UAPs likely have conventional explanations, such as atmospheric effects, sensor anomalies, or advanced human technology, a small fraction remains unexplained. The official stance is that these phenomena are being investigated primarily as potential national security threats or aviation safety issues. There is no official confirmation linking UAPs to extraterrestrial origins. However, the lack of conventional explanations for some encounters keeps the question open for public and scientific curiosity. It is crucial to approach this topic with scientific rigor, gathering more data and avoiding premature conclusions. Regardless of their ultimate origin, the study of UAPs underscores that there are still mysteries in our skies, and continued, transparent investigation is warranted to understand them fully. The universe always has more to show us. We stand at a fascinating moment in history. The scientific tools and knowledge we now possess are unprecedented. Telescopes are becoming more powerful, space probes are venturing to more distant and intriguing worlds, and our understanding of life's fundamental requirements is constantly expanding. The question of extraterrestrial life has moved firmly from the realm of speculation into active scientific inquiry. Many scientists believe that the discovery of life beyond Earth, particularly microbial life within our solar system, could be imminent. Perhaps it will happen within our lifetimes, maybe even in the next few decades. Such a discovery would mark a turning point for our species. Imagine the impact of confirming life on Europa, Enceladus, or Mars. It would tell us that Earth is not unique in its ability to harbor life. This would suggest that life could be widespread throughout the galaxy. The implications would be profound, affecting not only science but also philosophy, religion, and our entire worldview. It would force us to reconsider what it means to be human and our place in the grand cosmic narrative. The search requires patience, persistence, and international collaboration. Each new mission, each new observation, brings us a step closer to potentially answering that age-old question. The journey of discovery is as important as the destination itself. The ongoing exploration of our solar system and the universe beyond is a testament to human curiosity and our innate desire to understand. The search for extraterrestrial life galvanizes public interest in science and pushes the boundaries of technology. It encourages us to look beyond our immediate concerns and to contemplate the bigger picture. Whether we find simple microbes clinging to life in a subsurface ocean, or detect a faint signal from a distant star, any evidence of life elsewhere will be transformative. It will underscore the interconnectedness of the cosmos, and potentially unite humanity in a shared sense of wonder and discovery. Therefore, I encourage you to stay curious and engaged. Follow the news from space agencies and research institutions. Support scientific endeavors that seek to explore the unknown. Discuss these fascinating possibilities with friends and family. The quest to find life beyond Earth is a journey for all of humanity. The universe is vast and full of wonders, and the greatest discoveries may still lie ahead. The coming years promise to be incredibly exciting as we continue to probe the mysteries of the cosmos, searching for answers and perhaps for company. The story is still unfolding.